We requested to be removed from Amazon SES Sandbox. While they respond, let's explore in detail these three records. SPF, DKIM, and DMARC, the three pillars of email authentication. These tools are essential for preventing email spoofing, ensuring email authenticity, and protecting your domain from abuse. Whether you're managing transactional emails, marketing campaigns, or internal communications, understanding these protocols is key to maintaining trust and deliverability. Let's dive into how each of these works, their configuration, and best practices for implementation. The first tool we'll explore is SPF, or Sender Policy Framework. SPF specifies which servers are authorized to send emails on behalf of your domain. By publishing an SPF record in your DNS, you inform receiving servers which IP addresses or hosts are permitted to send email. When an email is received, the recipient server checks the SPF record to validate the sender's legitimacy. If the sending server isn't authorized, the email may be rejected or marked as spam. In Amazon SES case, our server is located in Virginia, US, East, 1. The syntax for an SPF record starts with V equals SPF1, indicating version 1. For example, V equals SPF1. IP4, 192.0.2.0/24. Include _SPF.example.com all. Here's what each part means. IP4 authorizes emails from a specific IPv4 range. Include references another domain's SPF record, such as third-party email services. All rejects emails from unauthorized sources. A few tips for configuring SPF. 1. Avoid exceeding the DNS lookup limit of 10 mechanisms. 2. Update your SPF record whenever you add a new email service. If a receiving server checks an email from example.com and detects that the sending IP address is not authorized in the SPF record, it might log an SPF failure, like SPF soft fail, unauthorized IP. To resolve this, expand your SPF record to include all authorized services or third-party senders. For example, V equals SPF1 include AmazonSES.com. Include _SPF.mail.hostinger.com all. Next, let's talk about DKIM, or Domain Keys Identified Mail. DKIM adds a digital signature to outbound emails using a private key. The corresponding public key is published in DNS. When an email is received, the recipient server validates the signature using the public key, ensuring the email wasn't tampered with and originated from the claimed domain. In practice, tools like Security Gateway allow you to create a DKIM selector, like default, to sign emails. The public key is published to DNS, and incoming emails are validated against it. This ensures both integrity and authenticity. Finally, we have DMARC, or Domain-Based Message Authentication, Reporting, and Conformance. DMARC combines the results of SPF and DKIM, allowing domain owners to define how receivers should handle emails that fail authentication. It also provides detailed reporting on email usage and spoofing attempts, giving you actionable insights. A DMARC record is a DNS TXT entry starting with V equals DMARC1. Here's an example. V equals DMARC1, P equals quarantine, PCT equals 50, RUA equals mail to reports@example.com. RUF equals mail to forensic@example.com. Let's break it down. P defines the policy, none, quarantine, or reject. PCT specifies the percentage of emails to apply the policy to. RUA email address for aggregate reports. RUF email address for forensic failure reports. DMARC reports come in two types. 1. Aggregate reports summarize email traffic sources and authentication results. 2. Forensic reports provide details on individual failures, such as spoofing attempts. our current DMARC for rewireweb.site is now set to v equals DMARC1, p equals none. But we will use a tool called postmark to create our actual record, which will be v equals DMARC1, p equals quarantine, our UA equals mail to reports at rewireweb.site. Mail to DMARC-failures at rewireweb.site, PCT equals 90, SP equals quarantine, SPF equals R, DKIM equals R.